Dear students, now we discuss power series method for solving differential equations. So, an infinite series of the form a0 plus a1x plus a2x square plus and so on, which we can write as summation n equal to 0 to infinity an x raised to n is called a power series in variable x. Here a0, a1, etc. these are constants. We can have power series in x minus x0 also. Okay, so it will be summation an x minus x0 raised to n. Now we discuss how to use this power series to solve differential equation. So what we do first, we assume that our solution is in terms of power series. That means we write y equal to summation a n x raised to n, where these ai's are unknown and we determine later on. We substitute this in given differential equation and then simplify. Then we equate like powers of x in that equation so that we get relations between these constants ai's and which will produce the solution. Okay. So let us illustrate this using some examples. First example is solve y dash minus 2y equal to 0 using power series method. So first we assume that our solution is of the form power series. Y equal to summation a n x raised to n equal to 0 to infinity. Okay. So this differential equation is 1. This is 2. Is solution of given differential equation. Okay. So we need y dash, let us differentiate to differentiating to we get y dash equal to summation. Okay, so it is d by dx of summation a n x raised to n equal to 0 to infinity. That is d by dx of a0 plus a1x plus a2x square plus and so on. So this is, first a0 is constant, derivative is 0, then it is a1 plus, here it is x square, so 2 times x, so 2 a2 x plus, next term is a3 x raised to 3, derivative is 3 a3 into x square plus and so on, or this may be written as summation n into an x raised to n minus 1. N is from 1. Okay, n is now from 1 to infinity. Okay, so this is 3. Now we substitute 3 and 2 in given differential equation. Substituting 3 and equation 3 and 2 in given differential equation 1, we get, so differential equation is y dash minus 2y equal to 0. So y dash is summation n an x raised to n minus 1, n is from 1 to infinity, minus 2y, so minus 2 times y is summation an x raised to n is 0 to infinity equal to 0. Okay, now we want to take these two summations together, so we rearrange terms. Okay, so first term is, in the first term we have x raised to n minus 1, and in the second term we have x raised to n. So we try to write both as x raised to n. Okay, so we replace n in first term by n plus 1, so that this will be x raised to n. Replacing n by n plus 1 in first term, we get so we have summation n plus 1 a n plus 1 x raised to n plus 1 minus 1, that is x raised to n. Okay, now here first term is x raised to n minus 1, so for n equal to 1 it is x raised to 0. Okay, so first term is a1. Okay, second term is 2a2x plus and so on. So here we need to write n equal to 0 to infinity. Okay, because we have replaced n by n plus 1, so we have to start from 0. So that first term is a1x. First term is a1, second term is 2a2x and so on. Minus 2 times summation an x raised to n equal to 0 to infinity equal to 0. Okay, now we write common summation for both the terms, so it is n plus 1 into an plus 1 minus 2an into x raised to n is 0 to infinity equal to 0. Okay, so this is important relation. Now right hand side is 0, which can be summation 0 into x raised to n. n equal to 0 to infinity. Okay, 0 plus 0, x plus 0 into x square plus 0 into x cube plus and so on. Okay, now we can equate like powers of x on both sides, and we have relation between the constants as n plus 1 into a n plus 1 minus 2an equal to 0. This is important relation which gives, and this is for n equal to 0, 1, 2 and so on. Therefore, we can have an plus 1 in terms of an. So 2 an divided by n plus 1. N is 0, 1, 2 and so on. Now we try to get the expression for an. Okay, this is recurrence relation. To find a10, we need value of a9. Okay, so instead we try to find expression of an in terms of n only. Okay, so what is a1 from this? If we substitute n equal to 0, we get a1 equal to 2a0, then a2. a2 means n equal to 1. So it is 2a1 by 2. But a1 is 2a0. So it is 2 into 2a0 divided by 2. Then a3 is 2a2 by 3, that is 2 into, this is a2. So 2 square a0 by 2. And this 3 in the denominator. So multiplied by 3 in the denominator. This can be written as 2 raised to 3 a0 by 2 into 3. So it can be 1 into 2 into 3. So it is 3 factorial. Similarly, a4 equal to 2a3 upon 4. But a3 is 2 raised to 3 a0 by 3 factorial. So this is 2 raised to 4 a0 upon 4 into 3 factorial. This is 2 raised to 4 upon 4 factorial a0. Now we can guess the general term. Therefore, an is 2 raised to n upon n factorial a0, n equal to 1, 2 and so on. Now we substitute this in equation 2, that is y. Now we know what is an. So we substitute in this equation 2. Okay, we can have solution y. Therefore, y equal to summation an x raised to n equal to 0 to infinity. It is summation an is now 2 raised to n by n factorial a0 x raised to n is 0 to infinity. Now a0 is constant, which we can take as common term. So a0 summation 2x raised to n, 2 raised to n into x raised to n. It is 2x raised to n by n factorial, n equal to 0 to infinity. This is the required solution. Okay. Now we know that the summation z raised to n upon n factorial is e raised to z. So this can be written as a0 e raised to 2x. Okay, so y equal to a0 e raised to 2x is required solution. Second example, solve y double dash minus x into y equal to 0 using power series method. Here we have variable coefficient equation. Okay, there is x into y solution. So first step is we assume our solution in terms of power series. Assume that y equal to summation a n x raised to n equal to 0 to infinity, that is a0 plus a1x plus a2 x square plus and so on is solution of differential equation 1, given differential equation 1. Okay. In this equation we need second derivative of y. Okay. So we find first and second derivatives. Therefore y dash equal to, okay, so y dash is differentiation of y, so it is a1 plus differentiation of a2x square, it is 2 times a2x plus 3a3x square plus and so on, which can be written as summation n into an x raised to n minus 1. But we want y double dash. Okay, so y double dash is 2a2 plus 3 into 2 a3 x plus next term will be, next term in y dash is 4a4 x cube. So derivative is 4 into 3a4 x square plus and so on, so that this is equal to summation. Okay, so this 2 is nothing but 2 into 1. Okay, so 3 into 2, 4 into 3, etc. Okay, so term is of the form n into n minus 1. Okay, 3 into 2, 4 into 3, etc. a3, so suffix is an, x raised to, here it is 3 into 2 x raised to 1. Okay, 4 into 3 x raised to 2, so x raised to n minus 2. Okay, n minus 1 into x raised to n minus 2. Okay, and in the first term we have 2 into 1, so n should start from 2. N is 2 to infinity. Okay. This is 3. We substitute 2 and 3 in 1. Substituting 2 and 3 in 1. we get okay, equation 1 is y double dash, so we have summation n minus 1 n x raised to n minus 2 n star from 2 to infinity. Okay, then we have minus x into y minus x into y. Y is summation an x raised to n is 0 to infinity equal to 0. Okay, now this x can be taken inside and it will be x raised to n plus 1. Okay, so uh, in both the terms we want same power of x so that we can simplify. In the first term we replace n by n plus 2 so that we get x raised to n. We replace n by n plus 2 in first term, and now second term, here it is x and it is x raised to n. So x raised to n plus 1 and we on x raised to n. So we replace n by n minus 1 so that it is x raised to n, and n by n minus 1 in second term. Okay, now first term becomes summation we are replacing n by n plus 2. So first term is n plus 2, second term is n plus 1. Okay, so n plus 2 minus 1, it is n plus 1. N plus 2, n plus 1. Then there is an becomes a n plus 2 and x raised to n. Okay, now here n starts from 2 and when n equal to 2 we have x power 0. Okay, so here we need first term as x power 0, so n should start from 0. Okay, second term is minus summation. Now we take x inside so that this is summation an x raised to n plus 1, and we are replacing n by n minus 1 in second term, so it is a n minus 1 into x raised to n plus 1. We are replacing n by n minus 1, so it is n x raised to n. Now what is first term? When n equal to 0, we have here x raised to 0 and here x, so it is x raised to 1. So first term should be x raised to 1. So n start from 1. And equal to 0. Okay, now remember that in first term we have n equal to 0. Okay, starting value is 0. In the second term we have starting value 1. Okay, so we have to consider the term starting from 1 to infinity and write the term for n equal to 0 separate. Okay, so therefore the separate term is with n equal to 0, so it is 2 into 1, that is 2, a 2 x raised to 0, that is 1, plus sum n equal to 1 to infinity, and now both are with x raised to n, so we can write n plus 2 n plus 1 a n plus 2 minus a n minus 1 x raised to n equal to 0. Okay. And equating like powers of x, we get, so constant on left hand side is 2a2, right hand side it is 0. So 2a2 is 0. That means a2 must be 0. And second thing is, all these coefficients for n equal to 1 to infinity are 0 because the right hand side is 0. Okay. So n plus 2, n plus 1 into a n plus 2 minus a n minus 1 equal to 0. This is for n equal to 1, 2 and so on. Okay. Therefore, a n plus 2 equal to a n minus 1 divided by n plus 2 n plus 1, n equal to 0, 1 and so on. Okay. This is a recurrence relation. Now we try to find values of all these terms, say a3, a4, a5 and so on. Okay. So let us substitute n equal to 0 so that we get just a minute. N should start from 1, not from 0. Now for n equal to 1, we have n is 1, so a3 is, n is 1, so it is a0 divided by 3, this is 3 and this is 2. Okay. Now we substitute n equal to 2. So that a4 is n equal to 2. So a1 divided by, this is 4, 2 plus 2, 4 into 3. Then a5 equal to 5 means n is 3. Okay, so 3 minus 1, 2. a2 divided by 5 into 4. But a2 is already 0. Okay, a2 is 0. So a5 is also 0. Note that in this relation, the gap is of 3. Okay, so n plus 2 and n minus 1 gap is 3. That means for a3 we need a0, for a4 we need a1, for a5 we need a2. Okay, so 2 plus 3 is 5. Okay, this is 0. Similarly, a8 will depend on a5. 5 plus 3 is 8. So that is also 0. Okay, therefore a8 is also 0. 8 plus 3, a11. a11 is also 0 and so on. Or in general, we can write a 3k plus 2. Okay. So when k is 0, it is a2. When k is 1, it is 3 plus 2, that is a5. When k is 2, it is 3 into 2, that is 6 plus 2, 8. Okay. When k is 3, it is 3 into 3, 9 plus 2, that is a11. Okay, equal to 0. K equal to 0, 1, 2, and so on. Okay. We get this important relation. That is a 3k plus 2 in C for k equal to 0, 1, 2, etc. Now we can find a6. A6 is now graph is of 3, so A6 equal to A3 divided by 6 into 5. But what is A3? A3 is A0 upon 3 into 2. So this is A0 upon 6 into 5 into 3 into 2. Okay. So this continues. And this is for multiples of 3. 3, 6, 9, etc. Okay. So A9 will be in the similar manner. A9 we can write A0 divided by, this is 9, so 9 into 8 into, okay. So A9 will be A6 divided by 9 into 8, and A6 is this one. Okay. So 9, 8, there is gap. 9, 8, 7 is not there. 6, 5. Now 4 is not there. 3 into 2. Okay. So in general, A suffix 3k equal to A0 divided by, this is 3k, so there is 3k, then 3k minus 1. Then there is gap. 3k minus 2 will not be there. 3k minus 3 will be there. Then 3k minus 2 will be there. Again gap, and so on. And last there will be 6, 5, 3, 2. Okay. 6, 5, 3, 2. Okay. And k is 1, 2, 3, etc. Okay. Now the term is A7. Now A7 equal to 7. Graph is 3, so 7 minus 3 is 4. So A6 is A3 divided by 6 into 5. So A7 is A4 divided by 7 into 6. Okay. But A4 is 4 minus 3 is 1. So A1 divided by this 7, 6 is there, and 4, 3. 4 into 3. Okay. So A1, from A1 we find A4, from A4 we find A7. So gap is 3. 1 plus 4 is 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. Okay. So similarly, A10 will be in the similar manner. A1 divided by this 10 into 9. There is a gap. We don't have 8. We have 7. 7 into 6, again gap. 4 into 3. Okay. Now we can write general term. So these terms are of the form, okay, 3k plus 1. Okay. So we already have computed a suffix 3k plus 2, a suffix 3k, and we only have a 3k plus 1. Therefore, a 3k plus 1 equal to 3k plus 1 means A4, A7, A10, then A13, and so on, equal to A1 divided by denominator should start from this number. Okay, here it is 10. Now we have 3k plus 1, then 3k, then there is a gap. We don't have 3k minus 1, we have 3k minus 2. Then we have 3k minus 1 also, and so on. Again gap and so on. Last will be 7643. And k is 1, 2, and so on. Okay, so we have computed all these terms. Okay, therefore y equal to summation an x raised to n equal to 0 to infinity. It can be written as, okay, so an we write in 3 terms as, first thing is a 3k x raised to 3k, k equal to 0 to infinity, plus summation a 3k plus 1 x raised to 3k plus 1 k equal to 0 to infinity, and third is summation a 3k plus 2 x raised to 3k plus 2 k equal to 0 to infinity. Okay, so these are all the terms summation a and x raised to n. Okay, so when k equal to 0, here we have a0 x raised to 0. Then in the second term k equal to 0 gives a1x. In the third term k equal to 0 gives a2x square. Okay, so a0 plus a1x plus a2x square, plus again k equal to 2 gives a3x cube. Here a4x raised to 4. Here a5x raised to 5, and so on. Okay, now we know all these values. Okay, 3k, a3k, it is a0. Okay, so it is equal to, a0 is constant, so maybe common, a0 into sum 1 upon 3k, 3k minus 1, there is a gap, 3k minus 3, then 3k minus 2, then again gap, and so on. And we have 6, 5, 3, and 2. In the denominator, we have 6, 5, 3, and 2. X raised to 3k. X raised to 3k. K equal to 0 to infinity. Okay. So this is first term, plus second term is a3k plus 1. Here it is a3k plus 1. It is in terms of a1. a1 is constant. It will appear everywhere. So plus a1 into sum, numerator is x raised to 3k plus 1, denominator is 3k plus 1, 3k, and so on. Then we have 3k minus 2. Then we will have 3k minus 3, again gap, and so on. Then we have 7, 6, 4, 3. 7, 6, again gap, 4, 3. Okay. K is from 0 to infinity. This is second term. Third term is summation a 3k plus 2 x raised to 3k plus 2, but all these are 0. A 3k plus 2 are 0, so we don't need to write that term. Okay, so this is the required solution. Note that this is second order differential equation, and there are two arbitrary constants a0 and a1. We cannot determine. Okay, so we determine all other terms in terms of these values. Okay, so this may be c1 into some function plus c2 into other function. Okay, so these two are constants appearing in the general solution. Thank you.